Hey, what's up guys? Thank you very much for being an electric. I appreciate that. Now, this is automatic transfer switch, okay? PLC controlled, all right? So, we did the relay-based. We did the ATS, the relay-based ATS. If you didn't watch a video, I will leave the link in the description, okay? Now, if you don't have any idea of PLC, you don't know what PLC is, or you know PLCs, but you've never, imagined that it could control the ATS also, then this video is for you, okay? And if you already know the relay-based circuit, then this is very easy and simple for you to, to learn this circuit, okay? So this is the board. Okay, let me show you what we have here. So if we start from the bottom here, we have SPD, okay? So it's good to have SPD embedded in your ATS. This will help you to suppress surges, spikes, that high voltage that can, happen in the milliseconds or in nanoseconds, so that kind of power can be suppressed by this, okay? So we have the earth terminal here, okay? Then right here we have the utility, your utility power breaker, okay? So we have your utility power breaker right here, then we have the generator breaker, we have the load breaker, okay? And then right here we have got the neutral terminals. Okay, so this is your neutral termination, and in this ATS we will have a common neutral point for both generator and mains. Okay, so this area here, it's our terminating point. So this board here will be, of course, inside a control box, and then whatever you want to display will come from here. So for example, here we have got our remote start can be connected, this contact, the panel indication like main available, main on load, they will come from here, gen running, gen on load, they'll come from here, okay? We have also an emergency switch in our circuit, so it's coming here, it's one of the main inputs, okay? So then we come to this area right here. This is where we have got our power contactors. So we have two contactors. These contactors have been mechanically interlocked. So you're able to see here, okay? So they are mechanically interlocked and electrically interlocked, okay? So from here we have these two small relays you're seeing. These are AC relays, and we are using these relays for interposing purposes. They are not really necessary because the contacts of this PLC, these are dry contacts, okay? So definitely they can handle the coil current for these contactors, but there is a reason why we have these. So if you need to have multiple contacts in case you want to do any feedbacks. So if you use a relay, you have multiple contacts available for you to use, okay? But for me in this circuit, I've used the relay, so the contacts, the dry contacts on the PLC will control the relay, and then the relay will now control the contactors, okay? And also, since we are not doing the interlocking in the PLC, we are doing the interlocking, electrical interlocks outside, so we are interlocking through the relay and also through the contactor. However, in the relay-based circuit, we usually have something, we want mains to be the priority, okay? So much as we do the interlocks, but we make sure that the main is the priority, and we do that in a relay. So the priority part, we've done it into the logic, okay? So we have a battery and a trickle charger here, and the reason to that is that our PLC is a DC. PLC is a 24-stroke or 12 DC, okay? And it is good to have this in your circuit. The reason being, if if the utility supply goes off, then the PLCs need to work because it has to send the signal to the field to call the generator, okay? And it's the same PLC that will energize the generator contactor. So if it loses power, then the entire circuit will die, okay? So that's why we have a battery and a trickle charger. Now this trickle charger is connected to the output or to the load breaker. So it has power throughout, and it will keep on, charging this PLC charging the battery, because the PLC can draw a lot of current. In fact, if you left this PLC on, because it's doing the job of holding all these components, okay, so it will draw, and it has an LCD also, it will draw a lot of current, and this battery may only be able to hold for maybe 2 days or 3 days, okay? So you need a trickle charger so that it will keep on, keeping the battery afloat, okay? Then, when we come to this section here, now here we have got our breakers or fuses right here, okay? These are 4, so the 3 are for our monitoring relay right here, okay? And then the 4th one is for trickle charger, so this one switches on the trickle charger. Then each phase monitor here has got a breaker, okay? Then when you come here, this is our PLC, this is Siemens logo PLC. Then we have got the breaker here, which switches it on. We have some connectors here, which is carrying the DC positive negative voltage. So that's where we get, if we need any DC, we get it from there. Then here we have got an AC relay. This is a generator relay, okay? This generator relay helps us to give us a feedback, because when the generator starts, this relay will engage, and when it engages, this is where we get the feedback signal, which we give to PLC to know that the generator is running, such that it can start counting the delay timer, then it engages, okay? The generator contactor, okay? So it is pretty easy like that, okay? So let us try to switch this on as I explain. So whatever you're seeing here, this is a control circuit, okay? So my trickle charger is on, okay? My trickle charger is on, so meaning that the battery is okay. So let us switch on our PLC. So the PLC is switched on pretty well, okay? So right now the circuit is off power, so there is any source of power that is available currently. So I want us to start switching on, and we'll see what happens, okay? So one phase is available. Remember, this is a 3-phase changeover switch. So all the 3 phases must be available for it to work. However, if you want a changeover to be single phase, that one is also possible. And if you want, you will tell me in the comment section, we can do that video. We can do that follow-up video later, okay? So we have red phase is on. We have got the yellow phase on. And then when we switch on the blue phase, we'll get a delay time of around 5 seconds. So when I switch this on, you see? So now it's counting. After that, our contactor has been engaged, okay? The main contactor has been engaged. Now, like I said, these contactors have been mechanically interlocked, okay? Mechanically, even right now, this one cannot come in because it's mechanically interlocked, which is one of the safety features. The second thing also, these 2 contactors have been interlocked electrically. So if this one is in, the generator will not come in, even if the command has been given. The other thing also, I have these 2 relays you're seeing here. They are also interlocked, Okay, I'll explain that later. Okay, now this logic is, so I'll share the logic on the screen. Okay, so this is what happens. This logic, if we switch off the main, if only one phase gets a problem, the contactor will de-energize, because that's how it should work. Okay, the contactor will what? Will de-energize. However, at this moment when the contactor de-energizes, a signal has sent. You cannot see that here unless we tested this with the generator physically, but this, one of my contacts here for a signal are live. So meaning that if you put a multimeter here, it can read to show you that the signal has been sent. When we do the test on the generator, we will see that. Okay, so meaning the generator will start. And let's see if the generator has started. So when the generator starts, this relay here comes on. And when this relay comes on, the timer will start counting the delay timer. Okay, there must be a delay timer such that the generator can warm up a bit. Okay, so when you switch on this one comes on, and the contactor doesn't come on instantly. So there is a timer here which is counting. And now you see our contactor has what? Has engaged. Okay. So now the generator has taken over, and the generator is now running the installation. Okay? All right. Now, in this old scenario, remember, if this power stabilizes, this is what will happen. When you switch off power and then the main is stabilized, it will start again counting before it engages. It doesn't engage instantly. Okay, it will start counting like 5 seconds. It depends. If your power is really poor, then we can even do up to 20 seconds. Okay, it depends how good is power. If your power is good, then if the power is good and stable, you can have that time lowered. But if the power is unstable, then you can increase. Okay, that time. Okay, now we switch that back on, and it will count. Okay, and then that has been changed. Okay, so because now the main is the priority, even when the generator here, it shows that it's still running. Okay, so in this case, if power goes again, this one enters because the generator was still running. Okay, okay, now this will change in a bit. Now, the other thing also which I want to talk about is, you will see it in the logic. I think I will do another video explaining this logic. Now, there is another thing I want to explain here. When you send the signal to the field, okay? So right now, if you measure here, the signal is active, so the generator is running. But the moment the main comes back, okay, it means that the generator will go in cool down, but we don't want that to happen. So we create another off delay timer in here, which will delay the off signal. Okay, so we can delay the off signal for maybe about 20 or 30 seconds. Okay, or even like a minute, 2 minutes, 3 minutes, depending. If your power is not good, not stable, then we can prolong that, such that the generator cannot just go into cool down, and then within a short period of time, this power it has gone off again, and the generator keep on starting, stopping, starting. You understand? Okay. All right. Now, you see the beauty of using a PLC is that you're not going to incur timer cost. Okay, you know timers can be actually expensive. Okay, so in our circuit, you realize that there is no timer in our entire circuit. Yet when we were doing the relay based, we had timers. Okay, so in this entire circuit, in the logic, I've used around 5 timers in this logic. Okay, and because the timer just embedded in the PLC, you just configure, so it is very, 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 very easy. So you realize that the PLC really works fine. Okay, better than the relay-based one, and it is very, very easy. So If you already know the relay based circuit, then the PLC can really be easy for you. The other thing is that the PLC has got extension modules, okay? So you can configure the inputs and the outputs the way you want, all right? Now I want us to talk about this panel indication. So especially we want to talk about like the main on load. So since you're using a smart PLC, this particular PLC, it has a web server inbuilt in. Meaning, you can have a web-based HMI. You can create an HMI, okay? And I will show you how. When you create that HMI, you can show generator running, gen on load, you know, main available, main on load. You can show all that information in HMI. And because it is web-based, and this, you can only connect this PLC on your local network, and then whenever you log into your computer on the same network, you can access the HMI. In fact, on also your phone using your browser, you can access the HMI because you're on the same network. It won't work if you're outside the network, but as long as you're on the same network, it will work. Of course, if you also want to access it remotely, you still can. There is a way you still can, because the PLC can go to the internet, can be connected to internet to wider network. Okay? So, if you're going to use the HMI right there, then you need feedback, okay? Now imagine you're on your computer, you are monitoring your ATS on an HMI, okay? And then probably this relay here maybe has a problem. The relay is burnt. But remember, the Q1 of the PLC is closed. So the PLC itself is telling us that the contactor has been closed. But the actual sense, this relay is burnt. And it's the relay that controls the contactor. Okay? So, if you had created your maybe indication here, then it means that the HMI will be showing you that the main is on load, yet this relay is burnt. Okay? So, if we want to know for sure that this main contactor is really on load or it has engaged, then we get the feedback from here. Okay? So we can take the normally open of this auxiliary contactor and we take it back to the PLC. Okay? And now when this contactor engages, the PLC have an input and then it will close the output, which now will be the indication. So when you see that on the indication physically on the panel and also the HMI, you will be sure that indeed that contactor has engaged. If the contactor is off, the HMI will tell you the exact thing that it is. You know. So you think through when you're designing your logic. It's not just a matter of, as long as the circuit works is fine. No. Okay? It's good to use feedbacks. Okay? So I'm going to show you another thing. So you see, since I'm using the battery here, I'm using the battery to back up this PLC or to supply the PLC and the electrical charger. So, if you're going to use this kind of ATS in your system, then the PLC has no limitation to create so many things, protection, displays the way you want. Okay? We can also create a kind of an alarm which is, okay, we can have a relay like this one. Let me show you. You see, this is a monitoring relay, okay? This is a monitoring relay. It monitors both AC and DC, okay? So, what happens is with this relay here, we can feed it. So we can feed it the DC here and it will be monitoring the battery voltage. Now in any case, this battery voltage, the normal voltage we can set it to be around 13.5. Okay, that's the normal voltage. So and then we set the threshold. So in any case, if the trickle charger is not working and then this battery voltage goes below maybe 11.5, then this relay here will give us an input. We'll create that and will give us an input here, because this relay, if you set the threshold, then when the battery go below like 11.5, then it will close. So definitely we'll get an input here. When that input comes here, then we can decide what we want. Because since we don't want to switch off anything, and this is not an alarm that is going to deactivate anything, but it's a warning, you know, to tell you what to do. Okay, so because in most cases these systems fail, then you follow up to see what's the problem. But in case the trickle charger has got a problem, we can have this to give the PLC an input. Then from there, we can have a display on HMI which will indicate that trickle charger faulty or battery voltage low. Okay, anything. So we can monitor, even you can decide to monitor both. You can monitor the trickle charger and we monitor the battery, both through relay. Okay, this kind of relay. So you see, it will be on the HMI, and the moment this battery is not charging, trickle charger has a problem, you will be notified. You're going to see that on HMI, that an alarm like low voltage. Okay, and the moment you restore this, the battery charges to the working voltage, and then the alarm will disappear. Okay, so that means that this can be good for retrofitting. Okay, so you already have a really best ATS, and you really want to use the PLC. That is going to be very, very, very easy for you. Now, also let me explain something else. You see, these two circuits have got a difference. So you have a relay based circuit, and then you have got the PLC based circuit. Now, the relay based circuit, the difference with that is that you really have to know the circuit. Okay, that's why someone will be like, do you have the circuit? Do you have the circuit? Because you need to know the circuit for you to be able to wire it. However, this PLC based, you don't need to know the circuit. Actually, you only have to know the logic. Okay, for instance, if I gave you this PLC, as long as it has a logic, you will just know that what goes to input 1, what goes to input 2, what goes to input 3. So it will always tell you, and it will come up with something like this, with just understanding that this goes to this, this goes to this, this goes to this. And then the output, you will of course know that the output Q1, it's the main contactor. You know, Q2 is generator contactor, Q3 is this signal, Q, you know, like that. So it becomes very easy. So the big deal with this kind of ATS, it's the logic. The rest of the thing becomes really, really very easy. So thank you very much for watching. I really appreciate. So let me talk about something quick. We didn't talk about the ATS. I mean the emergency switch. So this is an emergency switch. So most ATS must have emergency switch. Okay, not anything like this that has a control, it should have an emergency switch. Okay, and again, it's actually very easy to put an emergency switch on a circuit like this. How is that? You put it in the circuit here. You include it in the logic. So this emergency switch is not physically connected here. It's just inside the logic. So you just put the wire here, and then they will go, you know, and then so what we do, like we have a 24 volts DC, which will go directly and give an input here. Okay, so if I press right now, you see my circuit disengages. Okay, and regardless, so this affects the entire circuit, regardless whether the generator is running or the main circuit or the main contactor is running. You know, it doesn't matter. Okay, so it works. Okay, it works either way, and you see I've cleared it, and then the contactor engaged. Okay, so question for you. If your first time to see this kind of ATS, then you're welcome. Okay? If you need any more clarification, feel free. And you also go to the comment section and tell me which kind of videos you want to see. If you want to know if any circuit can be used into this, or any circuit can be converted into PLC system, then you can go ahead and say it in the comment section. Thank you very much for watching. Until next time, I'm out.